Okay, section 2.5 is called the absolute value equations and inequalities. This is the last section that we'll do in chapter 2. For example, let's let f of x be equal to negative x plus 1. Okay, and I want us to graph y equals f of x and y equals the absolute value of f of x. So y equal f of x is just a line. And y equals negative x plus 1 is a line that has a slope of 1, and y-intercept at negative 1. Okay. So when we graph y equals the absolute value of f of x, we would start by doing the same thing. We graph our line with a slope of negative 1, and only let's take a look at what happens with the y values being negative numbers. So when y is negative 2, okay, the absolute value of 2, negative 2 plus 1 is negative 1. The absolute value of negative 1 is positive 1. Okay. The absolute value of 3 minus negative 3 plus 1 is negative 2. And the absolute value of negative 2 is positive 2. Okay, and so basically, here's how this V-shaped graph comes into play. You've got a line, and somewhere on the line, you're going to flip all the coordinates to their opposite direction, and creating this V-shaped graph. Okay. As a definition, let's let a be greater than 0 and u be an expression involving x. Then u equals the absolute value of a means that u is equal to a or u is equal to negative a. Also, the absolute value of u equals the absolute value of a means that u is equal to a or u is equal to negative a. So as an example, suppose that we had wanted to solve the absolute value of 5 minus 3x equals 12. Okay. Step 1 that you want to do is write the two equations. One is u equal a, one is u equal negative a. So 5 minus 3x equals 12, or 5 minus 3x equals negative 12. Subtract 5 from both sides. And so negative 3x equals 7, divided by 3, x is equal to negative 7/3. Over here, negative 3x equals negative 17, and so x is equal to negative 17 divided by negative 3, which is 17/3. Now both these are going to be answers. Okay, check it out. If I plug in negative 7/3 for x, negative 3 over negative 3 is cancels. 5 plus 7 is 12. And the absolute value of 12 equals 12. Okay, how about x equals 17/3? Well, negative 3 divided by 3 is negative 1. 5 minus 17 gives me negative 12. The absolute value of negative 12 is 12, and so 12 equals 12, that's true. Okay. Another example, the absolute value of 2x plus 9 minus 4 equals 15. Okay, so the first thing that you want to do is get the absolute value equation all by itself. The absolute value of 2x plus 9 equals 19. And so 2x plus 9 equals 19, or 2x plus 9 equals negative 19. Subtract 9 from both sides, 2x equals 10. or 2x equals negative 28. 2x equals 10 means that x equals 5. 2x equals negative 28 means that x is equal to negative 14. Here's another equation. The 2 times the absolute value of 3x minus 1 plus 7 equals 3. Okay, if I subtract 7, then I've got 2 times the absolute value of 3x minus 1 equals negative 4. And divide by 2, the absolute value of 3x minus 1 equals negative 2. No solutions to that one. Okay, and it's not going to matter what x is. X can be anything. If x is any number, then the resulting expression on the left is going to be some non-negative number. How many non-negative numbers are equal to negative 2? None of them. So no solutions would be my answer. Now, in this particular problem, if I were to continue solving, I would have 2 answers and I would need to check, and both of them would end up being false statements. Okay, so let's take a look at another example. The absolute value of 4x minus 3 equals the absolute value of 6 plus x. X plus 6. And so, okay, well, the definition is going to be the same here. We got 2 equations, u equals a or u equals negative a. So the first one, u equals a, means that 4x minus 3 equals x plus 6, or 4x plus 3 equals negative the quantity x plus 6. When I subtract x and I add 3, 3x equals 9, means that x is 3. And here when I distribute the negative 1, negative x minus 6, when I add 3 and then add x, 5x equals negative 3. X is equal to negative 3/5. Again, both of those are solutions. Okay, let's let a be greater than 0 and u be an expression involving x. Then the absolute value of u less than a means that u is greater than negative a and less than a. And the absolute value of u greater than a means that u is less than negative a, or u is greater than a. Okay, so just like with equations, when we lose the absolute value bars, we form 2 inequalities. Okay, now u greater than negative a but less than a means that u is greater than negative a and u is less than a. So I got 2 resulting inequalities. Here's one way that I like to remember this and versus or business. Step 1, you need to get the absolute value of u alone and on the left. Okay, here's the absolute value of u and the absolute value of u. In step 2, if the sign is greater, write or. If the sign is less than, write and. And of course, if I split these 2 inequalities here, u greater than negative a and u is less than a, means that if the sign is less than, right, and. Okay, so let's take a look at inequality here, an absolute value inequality. Suppose that the absolute value of 3x plus 2 minus 6 is less than or equal to 4. Okay, the first thing that I do is add 6 to both sides. So the absolute value of 3x plus 2 is less than or equal to 10. And since that is a less than or equal to, I know I'm going to use my inequality here, saying that u is greater than negative a but less than a. A is 10. Okay, u is 3x plus 2. So 3x plus 2 is greater than or equal to negative 10, which is less than or equal to 10. I can split this into two inequalities and then solve. 3x plus 2 is greater than or equal to negative 10. 3x plus 2 is greater than or equal to 10. When I subtract 2, 3x is greater than or equal to negative 12 divided by 3. 3 is a positive, so x is greater than or equal to negative 4. Over here, 3x is greater than or equal to 8, and x is less than or equal to 8/3. So as my answer, I got the set of all x such that x is greater than negative 4, greater than or equal to negative 4, and less than or equal to 8/3. Okay, there's that statement written again as a single inequality. Or I can use interval notation. Negative 4 to 8/3 is the interval, and on my answer key, I would have two circles, and here I'm shading both of them, and anything between those two is going to be okay for an answer. Okay, anything that's on either side of those two numbers, I don't want. Okay, so another example about the absolute value of 7x minus 1 greater than 6. So here's my other inequality that I need to know. The absolute value of u greater than a means that u is less than negative a, or u is greater than a. Okay, well, that's what I've got. Or is a key word. So 7x minus 1 greater than 6, or 7x minus 1 less than negative 6. If I add 1 to both sides, 7x greater than 7 means that x is greater than 1. Or 7x is less than negative 5 means that x is less than negative 5/7. Okay, or is a key word that I need. I must have that word. What's wrong with combining this as a three-part inequality? So like x is less than negative 5/7, or x is greater than 1. Like, why not write it like that? Well, the problem with this is that you're saying that x is bigger than 1, but less than negative 5/7. So 1 is less than negative 5/7. That makes no sense. Okay. Or is a keyword that needs to be written in the answer. So the set of all x such that x is less than negative 5/7, or x is greater than 1, negative infinity to negative 5/7, or union, 1 to infinity. Now on the number line, I would have two numbers, and I'd be shading in opposite directions. That always happens whenever the keyword is or. Okay, whenever the keyword is or, you always have two numbers and you're shading in opposite directions. Whenever the keyword is and, you have two numbers and you're shading in between. Okay. Here's another one. The absolute value of 5 minus 5t greater than or equal to 7. Okay. Well, here's another greater than or equal to. 5 minus 3t greater than or equal to 7, or 5 minus 5t less than or equal to negative 7. If I solve this for t, subtract 5, negative 5t greater than or equal to 2 means that t, and I'd switch the sign back since I've divided by a negative, t is less than or equal to negative 2/5. And same deal over here. When I subtract 5, negative 5t less than or equal to negative 12, and divide by negative 5, I'm dividing by a negative, so I got to flip the sign. T is greater than or equal to 12/5. So in all, t is my variable. I want the set of all t such that t is less than or equal to negative 2/5, or t is greater than or equal to 12/5. And here would be that statement written as a inequality. I want brackets by the negative 2/5 and by the 12/5. And again, I probably could have looked at this to start. Since the keyword is or, I can know right away that on the number line I'm going to have two numbers, my two answers, and I'll be shading in different directions there. Of course, include the two values there, since we're including our numbers. Okay. The absolute value of 2x plus 1 less than negative 1. No solutions to this one. Okay, no matter what x is. If x is any number, the absolute value of 2x plus 1, I know is some non-negative number. How many non-negative numbers are less than negative 1? None of them. None of them. So no solutions would be possible in that one. Okay, now if I were to solve this inequality, this would be a rare time where I guess I would need to check my answer. Both the solutions would be numbers that would be producing false statements. And 2x plus 1, the absolute value, greater than negative 1. So how many non-negative numbers are greater than negative 1? All of them. All of them. It doesn't matter what x is. X can be negative 3 or 5 or anything. With the absolute value bars, you always have a positive number on the left, and all positive numbers are bigger than negative 1. Okay. The homework is on page 164. Here's the numbers that I'd like you to look at, and so we'll stop right there.